Let's try to understand asymptotes for reciprocal or rational functions. So this test problem is here to prepare you to understand reciprocal functions. And I'm going to extend this question so that once you understand, you can describe the characteristics of this particular function, right? Now, the question here is, write equation of asymptotes for y equals to 1 over minus x plus 2 minus 1. Now, these kinds of functions, which we can say transformed reciprocal function or rational functions, have two kinds of asymptotes. As you know, one is horizontal asymptote. And the other one is vertical asymptote. Correct? Now, how do you get these asymptotes? Vertical asymptotes are restrictions on the domain. You can never be there, right? You cannot cross these lines. These restrict your domain. And to find vertical asymptote is to equate denominator to 0. Since we cannot divide by 0, 1 over 0 is not meaningful. It's not possible, right? And so what we do here is we equate denominator to 0. And that is how we find vertical asymptote. In this case, the denominator is minus x plus 2. We'll equate it to 0 and we get 2 equals to x. And therefore, the equation of our vertical asymptote is x equals to 2. So we say our vertical asymptote for this particular case is x equals to 2. Since x equals to 2 is a vertical asymptote, we can write what domain is. Do you get the point? So we write now the domain is, now we say x belongs to real numbers, so that x is not equal to 2. Everything but not 2. So that is how we get domain of such a function. Now let's look into the range, which comes from horizontal asymptote. Now to find horizontal asymptote, what are we trying to say? We are trying to say that when x approaches a very large number, we call that large number infinity, then what happens? Does the y value approach a value? This is what. Then y approaches what? That is what we're trying to figure out. Now you could approach large number in both directions. That means minus infinity also. In that case, what does y approaches? This is what we're trying to figure out. Now look at like this. Let's put a large number here for x. So the equation is 1 over, let us say a large number. Let's say this is very large as compared to 2. I hope you agree with me, right? Okay, minus this time. And we have minus 1 here. So when I put this number here, I get something negative, right? I get something negative. So that means we are approaching negative 1, but from the negative side. Do you understand? We are just shy of negative 1. Do you understand? But what we approach is negative 1. This number, I should say this number, kind of, is almost 0. You see, this number equals to 0 approximately. And so we are left with minus 1. And so y approaches minus 1. If I put plus 1000 here instead of, I put plus 1000 which made it minus. Now if I put minus 1000 which will make it plus, in that case also, what will this number be? 1 over a very large number, right? But positive, do you understand? So let me take these cases separately. So we are approaching minus 1, but since we have put plus 1000 here, right? We are approaching minus 1, but we are shy of it from bottom side. Do you understand? That's so we can write sometimes minus here. So we are just shy of minus. But if I put instead of plus 1000, minus 1000, then I get minus of minus 1000, which will make it plus 2 minus 1. Now this quantity is positive. That means we are slightly more than minus 1, but still we are approaching minus 1, but we are slightly more than minus 1, but we are approaching minus 1. So that is what I'm trying to show you here. What are we approaching and how? To show this point, let me kind of explain you with the help of a graph. So when I have put plus 1000 here, this quantity is becoming negative. That means I am approaching minus 1, and minus 1 for me is a horizontal asymptote. This is my horizontal asymptote at minus 1. And when I plug in positive value, I am approaching minus 1 from this side. Do you understand? This is what I am trying to say. But when I plug in minus 1000, a negative large quantity, then this becomes positive, and I am approaching from this direction. Do you see that part? But in either case, we are approaching one value, which is minus 1. And therefore, we are not right there. We are approaching, and therefore this minus 1 is not in our range, correct? And so we get range from here. And the range is that y belongs to real numbers, so that y is not equal to minus 1. Do you get my point? So that is how we get domain and range for reciprocal transformed functions. I hope that's absolutely clear to you. Now I've done the needful for this, and similarly we also saw that vertical asymptote was at x equals to 2. So we'll have a vertical asymptote here at x equals to 2, right? So from here, I would like you to take the problem to the next level. Sketch the function. Sketch the function and write its characteristics. Characteristics will include intercepts, increasing, decreasing intervals, mainly, right? There is no more symmetry left here because we translated it left and right, correct? So those things now you can add to this and complete the question. That will be a nice practice problem for your test. Thank you and all the best.